Okay, so we now continue our discussion on conditional probability, and this part is probably more important than the previous one. Okay, but we have to start with comparison with the last example. Okay, so we're given the probability of A and probability of B and probability of A and B here. And if you still remember, we were talking about referencing this Venn diagram here. Okay, this is A, this is B, and this is A and B. Okay, let's get to an example that we use a tree diagram instead. Okay, the main difference is, what if we are not given this part? Okay, we don't need to deal with this part. Okay, all we're going to be dealing with are processes. So now let's consider this question. Okay, so we have 5 boys and 7 girls, and we're going to pick 2 students, but one by one at random. Okay, the key word here is without replacement. Okay, that means if I've picked a boy in the first time, okay, that boy will not be counted again in the second round. Okay, so that boy is taken out. Okay, so that's why conditional probability is used here. Okay, so in this case, let's try a tree diagram. So here you go, and on the tree diagram, let's put in all the probabilities. Okay, so this one would be 5 over 12, and this would be 7 over 12. Now, what do we put for this leg? Okay, what does this leg mean? Okay, it means that if the first draw is a boy, okay, what is the probability of getting another boy on the second round? Okay, so because it's affected by the first leg, so this would be 4 over 11, and of course this one would be 7 over 11. Okay, likewise, if the first draw is a girl, what is the probability of getting a boy in the second one? Okay, then this would be 5 over 11, and this would be 6 over 11. Okay, now to put all these into mathematical concepts, this would be probability of a boy in the first draw, probability of girl in the first draw. Okay, now a lot of you would say this would be probability of boy in the second round. That is wrong. Okay, why? Because if you call this as a boy in second round, what about this one? Okay, they're obviously two different things. These legs are actually conditional probabilities. Okay, this one is the probability of a boy in the second round given that the first round is a boy, and this one is the probability of getting a boy in the second round given it's a girl in the first round. Okay, here are the rest. Okay, so what about the outcome? What does this mean? This outcome means the whole path. Okay, it has to go through here and here all the way, and this will be the outcome. So we have 2 boys. This would be first boy, then girl. This would be first girl, then boy, etc. And so these are the probabilities. Okay, they are actually the intersection. Okay, first boy, then boy, and this one would be first girl, then boy. Okay, so these are the intersections. Okay, so for example, how do you get this one? Basically, you follow the whole path. This one, which is this, times this probability would give you this. Okay, so here's the path here. Okay, you follow the same path and you multiply together to get the intersection. But if we go back to what we've learned, okay, I could move this. Okay, it's an equation. I move this to the other side. What will happen? This is nothing new. This is exactly what we've learned. Probability of A given B equals to probability of A and B, or B and A, same thing, over the probability of the given thing. Okay, so this is basically, so these two are the same thing. We just move this to the other side. Okay, so back to our question here, probability of 1 boy and 1 girl. So there are actually two cases, right? this is one case, and this is another case. Okay, all these outcomes are different cases, so that means we add them together. So we have one case here and the other case here, first boy then girl, and first girl and boy. Okay, and the first case would just be this times this, okay, this one, plus this times this, which is this, and the answer would be 35/66.